Okay, this is the notes for section 1.6, and it is on solving equations. Your journal selection says, at this point, what do you believe the future holds for you? What are your post-high school plans, career choices, or college choices? This is a pretty easy journal. Make sure you give me quite a bit of detail to get the full points. Okay, the objective and what's the point? We are going to review the distributed property today and the solving of linear equations in the context of functions. So we're going to use functions to solve equations. Show that the distributed property works with fractions and decimals as well as integers. You may have only used integers in the past when you use the distributed property, maybe not, but we're going to use fractions as well as decimals today. Modeling real-world situations is a key part of math. It is not always to see how the numbers relate. Through practice, we will get better at this skill and be able to apply it in modeling situations that we come across in the future. Basically, the whole point of math is to be able to solve real problems in the real world, modeling real-world situations, and it's not an easy thing, so today is a good place to practice. Here we go. Words to know. Distributed property. You have seen this before. It has a number smushed up against a quantity. Remember that parentheses in math mean multiplication. So this number C, this variable in this case, is being multiplied by the quantity A plus B. Now we know that order of operations would generally tell us to add this first and then multiply by C. That's okay if you know what all the values are, but in this case we have all variables. So what we can do is you can take the C times the A and then the C times the B, and we keep this sign here. So we have CA plus CB. Okay, let's put some numbers in here to make sure that it works. 2 times 3 plus 4. Here we go. 3 plus 4 is 7. We know that. What is 2 times 7? 14. If we would have used the distributed property, 2 times 3 is 6. 2 times 4 is 8. 6 plus 8, guess what? 14. It always works out this way, and it's the distributed property. Okay? The next one is the opposite of a sum theorem. In this situation, we have a negative sign out in front of a quantity. This is saying the opposite of the quantity A plus B. This is just a fancy case of the distributed property. You could put a 1 there. In fact, I a lot of times do. And what we're doing here is we're distributing the negative 1. In which case we have negative 1 plus A, which is negative A, plus negative 1 times B, which is negative B. You don't have to write the plus the negative, but you can. You have negative A minus B or negative A plus negative B. Opposite of a sum theorem. I usually don't even call it that. I just call it the distributed property, but it's up to you. Okay? Recall, this should be reviewed because you have solved equations before. To solve equations, we need to get the variable by itself. I always say, what's our goal? And people will say, get the x by itself or get the y by itself. I'm sure you've heard that before. That is your ultimate goal when you're solving equations because we really want to know what does that variable equal. And things you need to remember is what you do to one side, you have to do to the other. That will keep it equal. You can't just add 3 to one side if I have 2 plus x equals 5. Actually, let's say, I can't just subtract 2 from here because then it's not equal. We know that this side and this side are equal. They both equal 5. So if I subtract 2 pounds from this 5 pound side, I also have to do it over here. And that's how we can figure out that x equals 3. Okay? Remember the power of that equal sign. You have to keep it equal. So if you do something to one side, you have to do it to the other. And to clear fractions, because sometimes you guys have a little panic attacks when you have fractions, you multiply both sides by the common denominator. Doesn't have to be the least common denominator, although that will make it the nicest. It just has to be a common denominator, and you multiply both sides, each and every piece. Okay? So let's jump in here and look at some examples. In example 1 in your textbook, it is on page 40. We are talking about a Monopoly game. Okay? In the board game Monopoly, Boardwalk is the most expensive property. The one-time cost of the property plus a hotel is $1,400, while the rent earned from another player landing on it is $2,000. If n is the number of players landing on Boardwalk, then this function f of n is, and I wrote it here so you can see it, 2,000n minus 1,400. Okay? This is how much profit the owner is going to make after n players land on it. So if somebody lands on it 4 times, n would be 4. If somebody landed on it 6 times, n would be 6. Let's take a look at where they got this from. This 2,000n comes from, it's $2,000 each time someone lands on the property. So if 4 people land there, it's 2,000 times 4, it's $8,000. That's how much money they made from people landing on it. Money from landing. And this $1,400, that is the overhead. So you have to take that out of your profit because that's how much we spent to begin with. So this is all your profit, but you have to take out how much you spent to begin with to figure out what your total profit is. Okay? So the question here says, what will be the owner's profit after 4 people land on Boardwalk? So what are we trying to figure out? We're trying to figure out what the profit is when n equals 4. When 4 people land on my property. So now I'm not looking at f of n, I'm looking at f of 4 because n equals 4. That's what they're asking us, if 4 people land on it. So what I do, I plug it in, get this out of the way. So now I have 2,000 times 4 minus 1,400. That's 8,000 minus 1,400. And we get 6,600. After you solve any word problem, it's good to think about the context. It says what will be the owner's profit. So we are talking about money here. You should give a money sign. And then you need to make sure that makes sense. Does that sound right? Well, yeah, I think it makes sense in the context of the problem. Each time someone makes 2,000, I would have guessed about, I probably would have guessed close to 7,000 if I was just going to guess without working the problem. Okay? Very good. The next part of the problem is asking, erase this. I'm going to erase this a little bit too. Okay. Is it possible for the owner to make exactly $10,000 from this problem? What am I looking for here? Am I going to plug in 10,000 for n? No, because that would say 10,000 people are landing. In this case, what I'm looking for is the whole profit, the whole f of n. I want to know, can I make $10,000 on that? So here, I'm going to plug $10,000 in for f of n. This one, f of n is 10,000. That is very, very, very different from n equals 4. This is saying the whole thing is 10,000. So this is the catch of the section. This is the most hard part of this section, is determining if you're going to plug in for n or if you're plugging in for the whole f of n. The solving is not going to be as big of a deal. What do you do first? I want to get n by itself, so I move the 1,400. How do I get rid of a negative 1,400? I add it to both sides. I now have $11,400 equals 2,000 n. Get n by itself, divide both sides by 2,000, and I get n equals 5.7. So is it possible for the owner to make exactly $10,000 in profit? Some people might say sure, n has to be 5.7. But we need to remember, what does n represent? N is representing players. So 5.7 players, let's think about that here. I'm kind of uncomfortable thinking about that because 0.7 of a person makes me a little squeamish. I don't know what 0.7 of a person is. So in this case, is it possible? The answer is no, because you can't have a partial person. We hope not. Okay? All right, now on page S1, there is going to be a list of the properties that you should already know. I'm not going to go through all these, mostly because you can't see them very well, but I'm going to just read them to you real quick. The closure property is one a lot of kids don't understand. Basically, that's just saying if you add 2 real numbers, you're still going to get real numbers. If you're adding elephants, you're still going to get elephants. It doesn't turn into a giraffe all of a sudden. So basically saying if you add real numbers, you're still going to get a real number. Same thing is true with multiplication. This will make more sense second semester when we talk about imaginary numbers. Okay, commutative property, remember when you commute to work, you go back and forth. This is saying things switch places. It's okay with addition and multiplication. It's not okay with subtraction and division, but this is just for addition and multiplication. Associative, who do you associate with? Who do you group with? This is about grouping symbols. This is using parentheses. Identity is saying there's two special numbers that give you what you started. With addition, it's 0. With multiplication, it's 1. And we talked about that when we did dimensional analysis. Inverse property saying there's some special numbers that can get you back to those zeros and ones, and those are called the inverses. Negative A when you add, and 1 over A when you multiply, and the distributive property we already talked about. I'm not so concerned with you knowing these by name. It was more important in geometry when you're working on proofs. But you definitely need to know how to use these because it's going to come into play when you solve algebraic problems. Okay, reflexive property, A equals A, duh. Symmetric says you can switch it back and forth. We do that all the time when it's easier to write things. Transitive property makes a lot of sense. If A equals B and B equals C, then A equals C. So if $1 is 10 dimes and 10 dimes is, what's 10 dimes? 20 nickels. Then $1 is also 20 nickels. Substitution property, we use that all the time. You can plug things in to solve. Addition property is saying add the same thing to both sides is legal, or multiplying the same thing on both sides is legal. Okay, so let's move along here. Back to Monopoly. You purchase 4 houses and a hotel on Illinois Avenue for a one-time cost of $750. You will earn $1,100 each time another player lands on the property. This time we're saying I players land on Illinois Avenue, then this is your profit. Again, 1,100 times I, $1,100 each time someone lands on it. Subtract your overhead, $750. So this is talking about our total profit. So what will the profit be after one player lands on it? That's asking what will the profit be if I equals 1. So this time we're looking at f of 1. Wherever I see an I, I'm going to plug in a 1 instead. 1,100 times 1 minus 750. And we get our answer of $350. Okay, very similar to the ones before. This time they want to know how many players must land on Illinois Avenue so that your profit is at least 15,000. So it's a little bit different. Still, we're not concerned with 15,000 people. We want f of I to equal 15,000. So this will require a little bit more difficult algebra. 15,000 equals 1,100 I minus 750. First step to getting I by itself, to figure out how many people need to be there, is we're going to add 750 to both sides. 15,750 people equals 1,100 I. Divide both sides by 1,100. And I got 14.3 players. That's how many players exactly need to land to get 15,000, and we know that's not possible. It's possible to have 14 or 15 players. So which one do I need? Well, if I plug in 14, am I going to get 15,000? No, I'm going to get something less than that. So it's not 14. We're looking at here 15 players. We will be rounding up. Okay? Now, the next one. This one is a little bit trickier to come up with the formula. The Monopoly one made a little bit more sense. These bank ones are a little bit more tricky. I hope that you can eventually write these on your own. Right now it's not as important that you are able to write problems of this difficulty with a function, but able to understand where their numbers are coming from. Okay? It's a little hard to read. It didn't transfer well from PowerPoint, so bear with me. Darius had $500 to spend at the baseball card convention. He decided to spend all his money buying the rookie cards of his 2 favorite players. At the end of the season, Darius found that the first card increased in value by 21%, while the second card decreased in value by 7%. So one made money, one lost money. He spent D dollars on the first card, so he spent 500 minus D dollars on the second. Okay? First card he spent D dollars, so say it cost $400. then how much of the second one have to cost? 500 minus 400, which is 100, because they had to total that 500. Okay, so that's where the D and the 500 minus D comes from. Now, where did this 1.21D that they're talking about and this 0.93? It says T of D equals 1.21D plus 0.93 times 500 minus D. Well, definitely this is talking about the first card, and this one's talking about the second card. So what is this 1.21 and this 0.93, where is this coming from? Well, the first one increased by 21%. So it was 100% would be the same. If I have 100% of $400, I still have $400. But I have 121% now because I had the 400 plus some. So that's where the 1.21 comes from. The 0.93 comes from losing money. I didn't get all my $100 back, I only got 93% of that back because I lost money. So always start with 100 and add or subtract the percent gain or loss. Okay, I just want to talk to you about what that formula meant in example 2. Okay, now this is example 2A. It's very similar to the baseball card example that was in your textbook, but a little bit different. Suppose you just received $50,000 inheritance. Woohoo! Sorry someone died, but that's exciting. At first, you decide to invest some of the money in a CD account that earns 6% interest and the rest of the money in a savings account that earns 4%. If X dollars are invested at 6%, then E of X equals 0.06X plus 0.04 times 50,000 minus X gives the interest earned in 1 year. If you want to earn $2,500 in the first year, how much money should be placed in each account? Okay, let's talk about where this function came from. We are going to invest all of our money. So X represents how much I'm investing in the 6% account. So 0.06 times X means I'm going to take 0.06 times however much money I invested. The rest of the money, this is the rest of the money, 50,000 minus however much I invested in the first one is getting 4%. And that is the savings account. Okay? Now, it might be confusing to you. You're like, well, why doesn't it say 1.06? It could say 1.06 if I wanted to know how much total money I made, but this function is set up to find out just how much interest only I'm making. So if I want to know total money, sure, I could throw in a 1 here because I'm gaining money, and I could throw in a 1 there, and that is perfectly legal, okay? But this was just set up to do the interest only, so they're not going to account for that first 50,000. Okay, so we're going to get a number less than 50,000 because I don't think we're going to double our money. And then we could add it to the 50,000 to figure out our total account. Okay, they told me I want to earn $2,500. So where do I plug that in for? Do I plug that in for X or do I plug that in for E of X? Okay, well, if I plugged it in for X, that's just saying I invested $2,500 into that account, and that's not what I'm looking for. I want to make $2,500 total in interest. So in this situation, I'm going to plug in E of X equals 2,500. And I don't know if I have much space here. So I'm going to do that on this blank sheet here. 2,500, because it was E of X equals 0.06X plus 0.04 times 50,000 minus X. I want it to equal 2,500. So this is some heavy algebra. Some of you might have forgotten, so I want you really to try to follow along here. Maybe do it yourself on your paper. Step 1, I want to get X by itself. Okay, I have 2 X's floating around here, so that's not very feasible right now. The first thing I'm going to do is what I call clean up the problem. There's nothing to do with this 0.06, but I'm going to definitely distribute this 0.04 just to make my problem a little bit neater looking. and it won't happen right away. So now I have 2,500 equals 0.06x plus what? Well, 0.04 times 50,000 is 2,000. 0.04 times minus x is minus 0.04x. Okay, it looks a little nicer. Don't have the parentheses anymore. And I still have two x's. So what can I do there? 0.06x minus 0.04x. That's called combining like terms. I hope you remember from algebra, and you did it some last year probably. I now have 0.02x plus 2,000. Because I have 0.06 minus 0.04, and I have 0.02. This is just a two-step equation right here. I can solve this. Minus 2,000 minus 2,000. 500 equals 0.02x. Divide both sides by 0.02. And I get x equals 25,000. Now, keep that in mind. I put the dollar sign because I do remember them talking about dollars, but what were they asking me? How much do I need to invest in each account? Well, 25,000 in this one. The 6% account gets 25,000 because that was what x equals. In this case, it works out the same because 50,000 minus 25,000 is also 25,000, but sometimes they will be different. So I do want you to be careful when you get an x value to make sure you put the right amount of money in the right account. Okay? You might have a couple questions about that tomorrow, and I'll be happy to answer them when you get to class. This is the most important problem of the section as far as problems that will show up later. It will show up probably on a quiz, test, maybe even later on a final. This is using a basketball example in your textbook, and we're going to use a basketball example again in the extra example. The tricky part about this one is there's going to be quite a few fractions. So we are going to have to get rid of the fractions in this to make it a little bit easier. It's not necessary. You could keep the fractions, just don't make any mistakes. Okay, so example 3A. Suppose during a 2007-2008 regular season NBA game involving the Celtics, Kevin Garnett scored 1/3 of Boston's points in the game. Ray Allen scored 1/4 of the points. The rest of the players scored 60 points. Write an equation to model the situation and determine how many points Boston scored in the game. Okay, the equation. So what do we have here? The Celtics. So the Celtics points equals what? Because that's what I'm trying to figure out. How many points did they have? Well, it looks like they had Garnett's points. So it equals Garnett's points plus Allen's points plus everyone else. I would have been in the everyone else category whenever I play basketball. Okay, the rest of the team scored 60 points. So this is a very important piece of information. The everyone else is 60. Okay, how much did Ray Allen score? Well, he scored 1/3 of all points. He did not score 1/3 of 60. He scored 1/3 of all points. So next thing we're going to do here is we're going to say, well, we don't know how many points there are, so I'm going to call it P for points. Garnett scored 1/3 of these points. So Garnett scored 1/3 of the points. All the points is this. So it was 100. Garnett scored 1/3 of them. I don't think it's 100 because I doubt Garnett scored 33.3 points. But you get the idea. So how many points did Allen score here? He scored 1/4 of the points. So this is your equation, and we already did the first part of this problem. Points equal 1/3 of the points plus 1/4 of the points plus 60. And we can solve that. I got it on the next slide here. So 1/3 of the points plus 1/4 of the points plus 60 equals P. Okay, you could totally use this, and you can add the fractions if you want, but what they're wanting us to do here is to get rid of the fractions. Do not make mistakes when you do this. It's supposed to make it easier, not harder. I look at the denominators, 3 and 4. Is there a common denominator you can think of? Sure, 12. I'm going to multiply this whole left side by 12 to get rid of those fractions. When I do that, these two sides are no longer equal. So I have to multiply this side by 12 also. So, and that's, a lot of you will forget that. Okay, so I have 12p here. And on this side, I'm going to distribute. 12 times 1/3. Some of you right now are reaching for calculators. You don't need to do that. What's 12 divided by 3? A fraction bar is the same thing as a division sign. 12 times 1 is 12. 12 divided by 3 is 4p. Plus 12 divided by 4 is 3p. Plus, a whole lot of you are going to forget to take the 12 times the 60. Do not forget to do that. 12 times 60 is 720. And this problem just got a whole lot easier. I have p's all over the place here, so I'm going to combine like terms. 4p plus 3p is 7p plus 720 equals 12p. Get the p's together. Minus 7p minus 7p. 720 is 5p. Divide by 5, divide by 5, and I get 144. 144 equals p. Go back to my problem. What was p to begin with? What did that even stand for? P was the Celtics points. So they asked how many points Boston scored. They scored 144 points. Now, they could have asked me how many points did Garnett and Allen score. We could have figured that out. You would just have to plug 144 into their spots to figure out how many points they scored. Okay? If you don't understand that problem, definitely ask me for help tomorrow because that problem will show up a few more times. Okay, here's another example. H of y is 13y minus the quantity 26 minus 3y. For what value of y does h of y equal 100? So they're saying the whole quantity h of y is 100. So plug it in for h of y. 100 equals 13y minus the quantity 26 minus 3y. Distribute this -1. This is the opposite of a quantity here. -1. So now I have 100 equals 13y minus 26. Because that negative is distributed. -1 times -3y is plus 3y. Be really careful with those. They ask you to make mistakes. 13y plus 3y, that's 16y. 100 equals 16y plus, oops, just kidding, minus 26. Add 26 to both sides to keep it equal. 126 is 16y. Divide both sides by 16 to get y equals 7.875. That problem wasn't really difficult. Just really need to be careful when you distribute that negative. And that's all she wrote for today.